Intent of this particular tape now is to familiarize you with two ideas that's used in finding the roots of y is equal to f of x. Now roots, this means where they cross the x-axis. Now the ideas that we want to discuss here is the idea of synthetic division, and that will be on the second part of the tape, and the first thing will be that of the remainder theorem, factor theorem. Now a lot of students will use a combination of these things. Some instructors will require that you just use the synthetic division. Now, if your instructor requires that you just use the synthetic division, this particular part of the tape won't be of that much benefit to you. So you might want to just look at that particular part of the tape or the second tape. Now, just as a matter of introduction, what we're talking about, you start off in the idea of mathematics is y is equal to some f of x. Now, don't let this kind of thing bother you. They're going to change this f of x and write a mathematical form for the f of x. They're going to say that f of x is equal to. Now, great big long thing that takes the place of your problem. They say you have some a sub naught x to the n power plus some a sub 1 x to the n minus 1. Now, don't let this confuse you. This is just the coefficient of the highest power that you've got in the equation. The a's are simply the coefficients that I have. The n's, the n minus 1, are simply the exponents. Then you have the next term, some a sub 2 x to the n minus 2 power. And this thing continues now. And I want to look at the next to the last term. Now, on the next to the last term, that's some a sub n minus 1 and has just the x. And generally, they just say x to the first power. They leave that thing off. And then they have what's called the constant term, a sub n. So again, now, this a sub n I'm very interested in, and this a sub naught, this so-called leading coefficient that I have over here, this is going to help me work my problem. But now, all of this garbage, and I call it garbage, is just a symbolism that they go through that replaces, it stands for all the problems that you have to work. Now again, a sub naught is nothing but the leading coefficient. It could be a 1, it could be something different from that. N is simply the highest exponential group that you have, or variable. That's the degree of this thing. Cubic would be a 3 in here, quartic would be a 4 in here, so forth and so on. So now, what they're going to do, the idea here is to find the solution set. Where does this curve, whatever it looks like, cross the x-axis? Now, suppose this curve looks something like this. Some animal that looks like this, and this is y is equal to f of x. All right, now, the question is, in this thing right here, where does this curve, y equal to this, cross this x-axis? Where, if possible, can I find these points where it crosses the x-axis? Now look, just one of these points here. If I were to take this point here, I would write P is equal to some, let's just say, R sub 1 and 0. Now look, you have an abscissa, and you have an ordinate, and this particular ordinate is y equals 0. So now, when you see this thing in mathematics, what they're going to do now is write this statement: let f of x be equal to 0. In other words, instead of y equal f of x, they say f of x is equal to 0. Find where this curve crosses the x-axis, and the only place that can be is where in this point P you have some ordinate here that's 0. You let y be equal to 0. And the question again is, where does the curve cross the x-axis? Now look, there's a multitude of points in here, and I'll refer back to this one. I want to put another point here. I'm going to call this point some P is equal to, now notice how I write this. I'm going to write it as R, some books use an A here, and I'm going to write it as f of x. Now, that's how a lot of them went. But I'm going to do one more thing here. I'm going to write this as f of r. So when I have any point P on this curve, I can write that as r, and f of r. So don't let all of this thing confuse you here. I have simply some point P that I want to look at and some special points. Where does the curve cross the x-axis? Okay, if you look at your worksheet now, get into this idea of the remainder theorem, I am interested in finding these spots where this curve crosses the x-axis. Now, here's the thing of importance here. The statement starts, if you look at your worksheet, the remainder theorem, it makes this statement to start with. If f of x is divided by x minus, and I'm going to do this, r. If it's divided by x minus r. Now, this is the key to the thing. I must always be dividing by this x minus r, or I'll have to manipulate these dividend that are the divisor so that I wind up with x minus r. Okay, now, if this x minus r, if I get a 0 when I do this in a minute, if I have enough mathematics, now look what I can do to this big, long, nasty-looking thing here. By using this idea of x minus r, I could rewrite this, the idea of remainder theorem, factor theorem, I could rewrite this thing as y is equal to, now a set of factors, if I have enough mathematics, x minus some r sub 1 times x minus some r sub 2 times some x minus, and it just goes on and on and on. And now let's say x minus some r, now let's say an n here. Again, I can just go 1, 2, 3, 4, 5, whatever this thing works out. The same number as this n that I have in this position. I could get this many factors down there. So if this were 3, and if the problem were a nice problem, I wind up with 3 factors here. If this were 4th power and it were again a nice problem, I could come up with 4 of these things. So now the idea is to take this thing here, this general polynomial, break it up into a set of factors. Then I'm going to set each factor equal to 0. That's where this idea comes into it. Solve for x. This will tell me the points where it crosses the x-axis. So, by using now the remainder theorem, f of x is divided by x minus r, I want to attempt to break one of these things down into a set of factors that look like that. Now, I'll be referring back to the picture and thing in just a moment. But now, look at the first example on your worksheet. In the first example on your worksheet, you have this statement, x minus 2, and you want to divide 2x squared plus x, or minus x plus 3 by this particular divisor, x minus r. Now, the division not work out in here. We're looking at a particular thing here. When you divide this, you get your quotient of 2x, I believe it's what, plus 3? And the thing you get down here is a remainder, in your first example, a remainder of 9. Okay, now, you already know how long it takes to go through this kind of division. But the idea of the remainder, this number that I'm looking for here, I really want a 0. And when I divide this thing, I come out with the number 9. So what I want to do is find a shortcut, let's call it a shortcut, where I simply can divide this thing quickly and see what the remainder is. Because if the remainder is 0, I'm interested in it. If it's not 0, I'm not interested in it. Now notice what I do here. I'm going to go to another notation here that you're familiar with. If I'm going to say that f of x is equal to 2x squared minus x plus 3, and I'm going to throw this thing in here. I want to find f of 2, just the number 2. Now, where did I get the number 2? All right, looking at this statement right here. If I say that x minus 2 is equal to 0, x is equal to 2. you must remember that I'm dividing by x minus r. So possibly I should write this thing as x minus, and I had the number 2 here. Now, if this had been a minus 2 I was using, minus a minus would make that a plus 2. Now watch the sign change in this thing here. You have to be careful about that. I am dividing by x minus 2. So mentally I say x minus 2 is equal to 0, x is equal to 2, and this is the number that I'm interested in. I'm going to call this little number right here, I'll refer to it on the sheet as my r. So if f of x is equal to this, I'm looking for f of r, and r is a 2. So now, plugging in everywhere, as you already know, covering your courses, this kind of notation, everywhere you have an x, you use this value. So this would give you 2 times then, 2 squared, notice the use of the parentheses in place of my x, minus 2 plus 3. So this would give me now, when I simplify, I would have 4 times 2 is 8, minus 2 plus 3. This would give me a value 9. Okay, now look, here is this 9 again, the same thing as I got in my remainder a while ago. So instead of having to divide this thing, what I want to do is devise a method where I can simply go, instead of this division and find the remainder, I'm looking for zeros. I want to quickly see what this number is. If it's a 0, I want to go ahead and make this division. But if it's not 0, I don't want to make the division. Now look, here's something of utmost importance you're probably not familiar with. This 9, even though it's not a 0, is very important. This right here, if you go back now and look at this point P that I've looked at on the curve, I said that any point P on the curve I could write as R and f of R. So in this particular problem that I've done, R would be 2, f of R would be 9. So this thing that I've just done is of importance to me because it gives me a point on the curve. I didn't get a 0. But I'm still not going to waste a thing. It is a point on the curve, and if I have to graph this thing, the more points I get, the better off I am. Now look, again, this f of r, this r that I'm using here, is the abscissa. That's my x value. Choose x. Turn the crank, out comes a remainder. This remainder is my f of r. This is my ordinate in this point P. So even though I didn't get a 0, this is of importance because it is a point on this curve, some point 2, 9. Not properly located, but the idea here. Don't throw these things away. They'll help you sketch the curve. But now, looking back at the idea I'm trying to get across again now. There is some kind of division, and remember I want to break this up into a set of factors. So a factor has to give me a remainder of 0. So I make this division, I'm guessing and all that kind of stuff, and I come out with a 9. That's not a 0. Well, I don't want to make this division first. What I would like to do is find this remainder, because if it's 0, then I want to do the division. I don't want to unless I get a 0. All right, I did the division, I got a 9. But now, I can do this quicker. Say f of x is equal to, this is my dividend, that long thing that I'm talking about. All I need to do is to replace this x with this x minus this r. Find this value of r. Now, to do that, I simply set x minus 2, my divisor, equal to 0. This will give me the number 2, which I'll call r. Use this number 2 here. Evaluate that, as you already know how to do, and it will give you a remainder very quickly. All right, look at your next example now on your worksheet. In your next example, you have 2x plus 3, and you want to divide now, though long division, 2x squared minus 3x minus 1. You do all of this work that you have. You come out with the x minus 3 as your quotient. and you get a remainder of 8. Okay, now, look at what I have here this time. This time I'm dividing by 2x plus 3. Now look, this thing said I had to divide by x minus r. X minus r. Well, that's not x minus r. But again, I can find that thing. I'm going to set this equal to 0. This will give me then 2x is equal to minus 3. X is equal to minus 3 over 2. So here is this r that I've got. Okay, now look. I'm going to take this value, and I'm going to say that f of x is equal to 2x squared minus 3x minus 1. And I'm going to find f of minus 3 over 2. F of minus 3 over 2. Now, plugging that in, this gives me 2 times minus 3 over 2 minus 3 times 3 over 2 minus 1. Now, this is squared. Now, watch out about this thing here. When you have an exponential operation, take care of that first. What you have here, when you square this, is plus 9 over 4. Okay, you have a plus 9 over 4 multiplied by 2. This, we'll do a little cancellation or reducing. This winds up to be 9 over 2. I'm not taking a shortcut here. I'm working this thing out. So this factor, this term that I have, is 9 over 2. Minus, what I have here is 9 over 2. This should be a minus sign in here, so that's a plus 9 over 2. Left my minus sign off. Then I have a minus 1. Okay, now, when you simplify this, you have 9 halves plus 9 halves. That's 18 halves, which would be 9 minus 1. This gives you a value of 8. So now again, I have determined this remainder much quicker by evaluating f of x at x equal r and come up with this thing right here. I can do it faster. Now the idea again is I am looking for a 0. Looking for a 0. I didn't get a 0, but don't throw this away. This again is a point on the curve. This point on the curve, I could write P is equal to R was minus 3 halves, and the ordinate would be a value 8. Even though I didn't get a 0, this is a value. That's a point on the curve. So quickly then, the idea here, as long as I'm dividing by x minus r. Now look, if this were x squared or x cubed, I can't do this kind of procedure. But it's just an x involved, x to the first power. I can set that equal to 0 and determine what r is. Now look out. It goes this way. Sometimes I have to go back this way. I take this number to find out what this divisor is originally. You have to go both ways on this thing, so be very careful about that. Watch your signs. If this is positive, this thing's going to be negative because I set this equal to 0. Okay, now, looking at example 3 that you have, now there's a comment before I leave here. If you were to divide this thing, instead of dividing by 2x plus 3, if you were to divide this thing by this thing here, minus 3 halves, just quickly, I would have x minus a minus. That would give me plus 3 halves. And I want to make a division. And this would give me 2x squared minus 3x minus 1. If I were to divide by x plus 3 halves, the difference is in the quotient. That thing would become 2x minus 6. But now, don't let that bother you because look what I have here. X plus 3 halves. And this 2x minus 6. Those things are basically the same thing. Common factor involved here. If I take this out when I look at the thing, the x minus 3. Now look, my original division originally was x minus 3. If I multiplied that by 2, I would wind up with what I have here. If I were to multiply this by 2, I would wind up with 2x plus 3. So you see, I'm playing with a constant factor here. You're always taking out a common factor if it exists. There is a common factor in this right here. I can factor out a factor 2 here. This would give me 2 times x plus 3 over 2. And this is the thing that I'm talking about that I'm dividing. So it doesn't have to be x minus r. It could be some ax minus some constant involved here. Okay, we want to look at another example. I want to look at example 3 on your worksheet, and it's stated a little differently. In example 3, it says find a solution set for a particular problem. This time we want to look at a problem x cubed minus 2x squared. Now I'm going to make use of this and try to break this f of x down into a set of factors. So I have f of x is equal to x cubed minus 2x squared minus x plus 2. Now the question on this one, find the solution set. Where does it cross the x-axis? I'm only interested in the zeros. Okay, so first of all, I want to start trying and find me some zeros. So it's a cubic equation. I'll skip me some spaces here, and I'm going to say try f of, if you look at your worksheet in this thing, the first thing that I tried was f of 1. Now, I don't know why I tried f of 1, simply because I've already worked the thing and I know the thing is going to work. If I try f of 1, this gives me 1 cubed minus 2 times 1 squared minus 1 plus 2. When I simplify this thing, this gives me a 0. Okay, I know then that this x minus this number is a factor of this original f of x. So now I can rewrite this thing as x minus this r that I have, minus a plus is negative. Look at that sign change. It's x minus this r that I have. Now, times something. Remember, I said if I wanted to make the division, I would do so only when I had a 0. So now look what happens here. If I make my division now, I'm dividing by x minus 1, x minus r, into this particular f of x that I have. That thing's the original problem that I have. Look what I have wind up with as the divisor, or the quotient. I get x squared minus x minus 2. When I make this division, and down here I get a remainder of 0. Now that's worked out for you on the worksheet. But now look, here is my other factor that I'm going to need here. So this gives me then, in this position, x squared minus x minus 2. I only want to make the division when I get a 0. And I have a remainder of 0, and this is the way it'll look. And the quotient, when I make the division, the quotient is my other factor that I need. Okay, now, when I get this down to a quadratic equation, I'm going to use the quadratic formula or factoring or completion of the square to finish this problem. In this case, this factors rather nicely, so I have x minus 1 times x, minus 2 times x plus 1. And it says find the solution set. I'm going to let this be 0 now. Y is now a 0. Now, to finish this thing off, you set each factor equal to 0. That gives me here x is equal to, let's just put it in, x minus 1 equal to 0, x minus 2 equal to 0, x plus 1 equal to 0. And my solution set, I'm going to write it here. The solution set, x is equal to, this crosses the x-axis now in 3 points. 1, 2, and minus 1. So this original curve crosses the x-axis in 3 spots. 1, 2, and minus 1. Okay, now let's go back and look at this thing. F of x is equal to this. I am going to try some numbers. 1, 2, 3, 4, 5, and I'm going to be careful what numbers I use here. Talk about that in a minute. I'm not going to try every number here. I put this in, turn the crank, and when I get a 0, I want to then make my division, because I now can write this in factored form. After I get it in factored form, now I may be able to factor this, I may not. I'll set each factor equal to 0, solve for x, and it tells me where it crosses the x-axis. So, going back and looking at the original idea, I start with some f of x is equal to some polynomial. And it is some curve y is equal to f of x. What I'm interested in is where does this curve cross the x-axis. In this case, the one I just worked, 3 points it crosses the x-axis. Now, these are not right because I have some positive values, 2 positive and 1 negative. But I'm looking for this r sub 1 in 0. If I've got enough mathematics, I can break this thing down into a set of factors, x minus some r sub 1, x minus some r sub 2, and so forth and so on. So I start plugging in values into this long polynomial, 1, 2, 3s, and I turn the crank. If I get a 0 across the x-axis, I then make my division. If I don't get a 0, I don't throw it away. This is a point on the curve y is equal to f of x. So now, some comments that you look at now in your worksheet about this kind of thing. And this example 3 now is worked out in detail for you with the steps involved. But notice down here where it says note. All right, just some discussions here. I have basically, looking back at this original problem, I have some ideas that I really want to get across because I'll use them here and in this next idea. First of all, if a sub naught is equal to 1. All right, if this is a number 1, such as it was in this example 3, all factors, now these are all possible factors, are factors of this a sub n. In other words, I started here a while ago in example 3, that was the number 2. Now look, I am not going to try anything but the numbers 1 and 2. That's the only things that might give me a 0. Now, plus or minus in this case. I don't know which ones, but that's the only thing. I am not going to put a 3 into that example. It will not give me a 0. So, very important idea here. If this leading coefficient is 1, the only numbers you have to try are factors of this a sub n. Okay, now look at another idea. If this a sub naught does not equal 1, like a 2 or 3 or something like that, all possible factors are factors of, now look, a sub n over a sub naught. Now, I have to do some work with this. This whole idea, these two ideas here, I'm going to call possible factors. These are my possible factors. I only want to try those numbers. All right, now look. Suppose that this f of x is equal to, suppose I have some 2 times some x to the n power, and my constant term is something like 6. All right, possible factors now. I'm going to write this as possible factors. I have factors of 6 over 2. Now look how I handle this situation. In the numerator, the factors of 6 are 1, 2, 3, 6. In the denominator, the factors are 1 and 2. And now let's consider this as a fraction, basically. But now, what I'm going to say here is that you have two sets of factors now, or possible factors. And this is an easy way to find the numbers that you want to try. First of all, the first set of factors, now here's what I'm going to do. I'm going to take all of these numbers over the number 1. Then I'm going to take all of these numbers over the number 2. Then I would take all of these numbers on the next one that I had. So my first set of factors, I have 1, 2, 3, and 6, all over 1. My next set of possible factors, 1, 2, 3, and 6, all over 2. But now, all of these up here would give me the numbers 1, 2, 3, and 6. The numbers down here, I have 1/2, 2 over 2. I've already got that in there. I've already got it previously up here. I would have 3 over 2. Then 6 over 2 would give me the number 3, which I already have listed here. So the possible set of factors, plus or minus now, this particular thing here. Look, another example. Now, remember, the whole idea is to find a 0. These are the only numbers that might give me a 0. So suppose this time, have a situation, and I have something like, say I have 3x to the n power and say 12. Possible factors again, I look at 12 over 3. All right, now, the factors of 12, I have 1, 2, 3, 4, 6, and 12. In the denominator, I have possibility of 1 and 3. So I have two sets of factors again because of my denominator. I have set A. In set A, I just write this numerator over the value 1. So I have 1, 2, 3, 4, 6, and 12 all over 1. My second set of factors, I write all of these numbers over this second number down. Now I could have 3 numbers, 4 numbers, or 5 numbers in the denominator. That determines the possible numbers I'm going to try. 1, 2, 3, 4, 6, and 12 all over 3. These can be plus, they can be minus. These are the only numbers that might give me a 0. So now, when I start simplifying, find the solution set, I only want to try these numbers. Now, don't try the number 5 in this situation. It will not give you a 0. It'll give you a point on the curve, but it will not give you a 0. You are trying to find the solution set. Where does the curve cross the x-axis? Don't try every number. Only try those numbers that might work. Set you up a set of possible factors. Now, one thing more on your worksheet. When I try a number, suppose I try the number 3. And I turn the crank, and 3 gives me, say, an 8. Not 0, a number not 0. Listen, if I try the number 3, it does not give me a 0. It will never give me a 0. Throw it away. Never try it a second time. So this is what you have down in your comment here. Evaluating this if C part, if f of r does not give me a 0, it never will give me a 0. Throw the thing away. Okay, now, one other thing on your worksheet about evaluating f of r and f of minus r. I want to go back now and look at the problem I have just finished and just illustrate this point here. Now, when I did this problem, racing this, right here I have f of 1. Now, f of 1, when I did the problem, it gave me a 0. Now, what I'm interested in here is illustrating something to you here. From this set of numbers that I have, I try f of r first. From this set of numbers, I could try f of, say, minus 1 immediately. Hey, and I've already got this thing worked out if you pay attention. Look, I'm going to call this f of a, like the plus 2 and the plus 3. I'm going to call this f of minus a, the minus 2, the minus 3. When I use this factor theorem, I always try 1 and then minus 1. I always try 2 and then minus 2. I always try 3 and then minus 3. For this reason, now look what happens with f of minus 1. And I'll write this above here. This minus 1 cubed, then I have a minus 2 times a minus 1 squared, minus a minus 1 and a plus 2. All right, now, when I simplify here, look what happens here. I've got a 1. I've got minus 2, minus 1, and a plus 2. This and this are called my odd-powered terms. The only difference between f of 1 and f of minus 1. Now look what happens here. This becomes a minus 1. This is a minus 2. This is a plus 1. And I have a plus 2. Now look what happened to these terms. These terms, the odd-powered terms, the only difference. When you do f of a, immediately write down f of minus a. The only difference is the odd-powered. Now not the odd-numbered terms up here. The odd-powered terms, the x cubed and the x, that's my odd power. Simply change sign. So when you do one of them, you immediately have a second one. Already you have the values. You just need to change the signs in them. So remember these little comments and things we'll be using now throughout the tape that we have. Okay, this example we'll look at now is on your worksheet, selected problems. But I want to run through the idea, selection of my possible factors, and work through this particular example. All right, now, notice that the leading coefficient is different from 1. I'm going to have to determine my set of possible factors. Now, I generally do this in the margin of the paper. So my possible factors now are factors of 3 over 2. These are my possible factors that I want to look at. Now with the number 3, in the numerator I simply have 1 and 3. In the denominator I have 1 and 2, considering them kind of like a fraction. Two sets of factors here. A, I have 1 and 3 over 1. B, I have I have 1 and 3 over 2. So in this first set, that gives me the numbers 1 and the number 3 to try. In this second one, I have 1/2 and 3/2. So of all the numbers that exist, these 4 numbers, plus or minus, these 4 numbers are the only numbers I'm going to try. Now listen, this saves you a lot of time if you will find a possible set of factors. All right, now, this is generally how I start the thing. I generally say, well, there's f of a and f of minus a. So I simply start hunting in this thing, trying to find something. So now, first thing I try then, say, is f of 1. I always do that because that's the easiest one there is to form. This gives me then 2 times 1 cubed plus 1 times 1 squared, 6 times 1 plus 3. So when I simplify this thing, this gives me 2 plus 1 plus 6 plus 3. Now look, immediately, f of minus 1 is equal to my odd-powered terms. That's this one and this one. These things going to change sign. That's the only difference I have. So that gives me then f of minus 1 is a minus 2 plus 1 minus 6 plus 3. Just the odd-powered terms change sign. So now when I finish this, notice what I have here. These are all positive. Okay, now this tells you something. They'll discuss this in class. Man, I'm never trying another positive number. That's the thing not going to work. Okay, but anyway, this gives me what? 9 and 3 would give me 12. There is a point P on the curve at 1, 12. That's a part of my curve. F of minus 1, now look what happens here. I get a minus 2, a minus 6, be minus 8, and a plus 4. This gives me a minus 4. Now look what happened to my curve. Between 1, which is a plus 12, at this number 1, I'm way up here at plus 12, and at minus 1, hey, I'm down here at minus 4. That curve had to cross the x-axis between 1 and minus 1. So normally now I would do, say, the plus 3. But look, I found out something right here. If this changes sign, that thing had to cross the x-axis between there, or it's what they call in mathematics discontinuous. Hey, if it's discontinuous, you need another course before you talk about that. So what I'm going to do now is pick up my fractions between 1 and minus 1 is the next thing I want to try. Okay, I only have one thing to try here. I have to try plus 1/2 minus 1/2. That's the only fraction I have between 1 and minus 1, the only possible number that might work. So, trying now f of 1/2. Now, really in this thing, I said a while ago I didn't want to try a positive number. I knew it wouldn't work, but I'm going to go ahead and put the thing in there. F of 1/2 will give me, from my original problem now, I have 2 times 1/2 cubed plus 1/2 squared plus 6 times 1/2, then plus 3. When I simplify this now, 1/2 cubed, that's 1/8. 1/8 times 2 is 1/4. So the value of this term, 1/4. Plus 1/4 plus 3 plus 3. And when now look, before I go any further, f of minus 1/2. Hey, I've already got that thing ready. All I have to do is change some signs. Odd powered term. This changes. That stays the same. This changes. Hey, that's 0. Right quick, that's 0. I found something I'm looking for. I found me a 0. So now I know I can make a division. Now, this up here, just finishing the thing up, that would be 3 and 3 is 6, 1/4 and 1/4 is 1/2. That gives me 6.5. Of course, I knew it wasn't a 0 anyway. But look, I found a 0. So now I know I can write my problem as x minus whatever that number is. That number was minus 1/2 that gave me a 0. So minus a minus makes that plus 1/2 times. Okay, now look, I have to find this other factor. I got me a 0. Now I'm ready to make my division. So, dividing this thing out, I have x plus 1/2, and I want to make my division of 2x cubed plus x squared plus 6x plus 3. Now look, I already know this is going to be a 0. X would divide that 2x squared, running through the division process now. This would give me 2x cubed plus 1/2 times 2 would simply be x squared. Go through my sign changes that you have in your division. This would give me a 0. This will give me a 0. So I'll bring down then my next term, 6x plus 3. X would divide that plus 6 times. Multiply, I have 6x plus 3. Sign changes. Hey, I got a 0. I knew I had a 0. But this now is the thing that I'm interested in. This is my other factor. So my other factor in my problem is 2x squared plus 6. Okay, now, when I get a 0, I'll make my division. And you'll find out in the next tape the easiest way to do that division is by synthetic division. It's a lot quicker. It's a lot easier. But now, when I get this to a quadratic equation, I'll use the factoring or quadratic formula or something like that. Now look, this is a pure quadratic. We mentioned on that tape quadratics by factoring. When you have a problem of this type, what you do is simply set that equal to 0 and solve. This gives you 2x squared is equal to 6, or minus 6. X squared is equal to minus 6 over 3. x is equal to plus or minus the square root of a minus 2. Oh, excuse me, this should be a 2 here, this would be a 3. Now look, on your other tape, depending upon what the instructor wants here, look, I say it did not cross the x-axis here. That curve only crosses the x-axis one time. Some instructors say, go ahead and finish this thing. So you could write this thing as x is equal to plus or minus 3i. Now, this depends upon the instructor. As far as I am concerned, you answered the question, where does this cross the x-axis? Now, this one doesn't cross the x-axis with this factor. So now, however you write the solution set, I'm going to write two solution sets here. The solution sets, x is equal to, you have a solution set, set each factor equal to 0 and solve, you have minus 1/2 for this thing right here. So if you were, say, working for me, that's the only place it crosses. Set this equal to 0, solve for x, you get x is equal to minus 1/2. Because this other factor did not cross the x-axis over here. Now, or you could write, depending upon your instructor now, you could have x is equal to, you would have, again, the minus 1/2, same thing as we got. Then the other factors would be plus or minus 3i. Now, the directions for this, or the instruction says, find all the possible rational roots. And I say that's not a part of the answer because that's not a rational root. I don't care where you are. You find out where it crosses the x-axis. And this factor, when you set it equal to 0, does not cross the x-axis. So rational roots, this would be your answer here. But again, it depends upon your instructor. So be very careful about it. All right, now, maybe this particular example, throwing it all in, will satisfy. Now you need to do the example problems in the back of the worksheet. Work these things out. Show all your work again. If you have any difficulty with the thing, or is there something here we mentioned that you don't understand, go talk to your instructor on the thing. Now, the next tape will be on the synthetic division. Now, remember I said to you, this is a whole lot easier to divide if you know how to do synthetic division. And some instructors say, just a synthetic division is sufficient. I don't need this anyway. This depends upon your instructor.